Okay, this video covers sections 10.2, which deals with frequency tables, histograms, and stem and leaf plots. Talking about some background vocabulary here. For starters, you'll see an example of stem and leaf plots. That's what we're going to get into first. Number one says to identify the parts of the following stem and leaf plot. So if you look over here at the bowling scores, we have some sample data. In a stem and leaf plot, the stem is simply all the digits other than the last digit. So the stems would actually be in this little column right here, and they're listed in consecutive order. The leaves are the last digit of the data values, and they're listed from least to greatest from the stem. So everything over here would be considered your leaves, as well as on this side. As far as the key, this is down here, and this tells you how to interpret the graph. And on this particular graph, the first example here on the key is showing 14 inside the bars, and then the one on the right-hand side, that's referring to this data value right here. And the second part of the key, if you take a look, shown right here, this 3 and the 14 inside the bars, that's referring to this data value right here. As far as number two, what conclusions can you make from looking at the stem and leaf plot above? Basically, if you take a look, they're pretty similar, but these three data values right here, I would say that shows that Marty is definitely a little bit better bowler than Bill because he does have the higher values. Okay, moving on. Looking at example 3, this represents the season scores for the football teams going to the state championship. I have to say this data looks a little bit high, but we're going to go ahead and go with it. We're looking at Upper St. Clair data and Bethel Park data. Now, for starters, before you get into making a stem and leaf plot like this problem asks you to, you do have to list the data from least to greatest, which I did. Upper St. Clair is shown right here, and Bethel Park is shown right here. Okay. I titled the graph here the stem and leaf plot, and what we have to do first is identify what our stems are going to be. And if you take a look at Upper St. Clair, it looks like the smallest stem we have here is a 4, and the biggest stem we have here is a 7. Bethel Park ranges from a 3 to a 6. So it looks like we're going to go with stems ranging from 3 all the way up to 7. And what I'm going to do is simply use my Upper St. Clair data first, and I'm going to write all the data values. The first 42 would be shown right here. We have a second 42, and we do actually list that twice because we want to represent all the data values. We have our 45, and we have our 49. And then with the 50s, we have our 55, our 56, our 58. In the 60s, we have a 61 and a 65, and then we have the 72. Notice how these data values are listed right on top of one another. They're not staggered or uneven, and there are no commas being shown. For Bethel Park, we're going to do the exact same thing. And we have a 37 right here. We have two 48s. We have a 49, 52, 57, 58, 60, 61, and 63. And you should always do a quick double check and make sure you have the same amount of data values and it represents all the data. And I did that. I do have 10 values listed for Upper St. Clair and 10 values listed for Bethel Park. Now the last thing to do is go ahead and create an actual key here. So I'm going to put that in the bottom right-hand corner. And I'm going to show one of my examples as this. And this is representing the number 37. That would be shown right here. And I'm going to put a second example here showing a 2 and then a 4 with a bar in it. That's representing the number 42, and that would be shown right here. So that's basically a completed stem and leaf plot. Now we're going to move on to frequency tables and histograms. Frequency, with that, it's simply of a data value is the number of times it occurs. With a histogram, it's simply a bar graph used to display the frequency of data divided into equal intervals. And then a cumulative frequency table shows the frequency of all the data values less than or equal to a given value. And we'll show you an example what that's all about. Looking at this example here, what we did is we took the data values from 2 seasons ago. It's the Steelers scores from 2015 and 2016 season. And if you're looking at it and saying, wait, that's a whole lot of scores, keep in mind this represents the preseason games as well as the playoff games. And the problem is asking us to make a stem and leaf plot. So what we have to do is kind of go ahead and get all these data values listed. I'm going to pause it right now, and maybe you can go ahead and try this totally on your own. I'm going to go ahead and rearrange the numbers in order. So why don't you do the same? I'm going to hit pause. Okay, because of space concerns, I went ahead and listed my data values down at the bottom. and I counted there were 23 data values here, and I have 23 down on the bottom. So in creating my stem and leaf plot for the Steeler values here, I'll go ahead and do this in blue. My stems are going to be 0, 1, 2, 3, and would actually need one more line there for the 4 since we had scored 45 points one time. And all I'm going to do is simply go ahead and fill in the data values. Now, again, I'm going to hit pause. Why don't you try to complete the entire stem and leaf plot while I fill it in, and we'll kind of look at the final answer together here. Don't forget to include your key when you're through. Okay, I'm back here. I went ahead and completed my stem and leaf plot while you're gone, or while you're trying yours. And if you take a look, I have my 23 data values shown right here. I went back and double checked. And again, keep in mind, everything lines up perfectly and there are no commas. And we work from the inside out, going smallest to greatest. I chose to use a key value of 30 over here. I wrote the 3 and then the slash and then the 0. And that would represent this data value. So that's essentially what a completed stem and leaf plot would look like. Now, based on that data, they're asking us to make a cumulative frequency table. This might be something new to you, but all you do is you essentially break the data down into score intervals. So what I'm going to do is say, okay, we have a score interval ranging from 0 to 9 points, from 10 to 19, 20 to 29, 30 to 39, and we have that extra row here, 40 to 49. Notice how these are in equal increments, and essentially it's broken down by the stems. These are all the stems that start with 0. These are all the stems of 1, stems of 2, stems of 3, and stems of 4. And as far as the frequency goes, you'll have to go back and look at your actual stem and leaf plot that we created. But twice we had data values ranging from 0 to 9. That's when the Steelers scored 3 points and 6 points. On 8 occasions, they scored between 10 and 19, 7 occasions between 20 and 29, 5 occasions between 30 and 39, and the one time they scored 45 points. And a nice little check here is if you add up all those values, that should be equal to the number of data values you have. Now, the cumulative frequency is simply a running total. We had a total of 2 values from 0 to 9. We had 10 values from 0 to 19. That's the sum of these two frequencies. Okay, so we're essentially just adding the previous frequency to whatever our current cumulative frequency is. So right now we have a total of 10 values. We have 7 more in this next interval, so that adds up to a total of 17. We're going to add 5 more from here, taking us to a total of 22, and then this last value, which takes us to a total of 23. Okay, so this number here should represent how many data values you have. Now over here on the bottom right-hand corner, this isn't exact, but if you look at the data, it looks like about half the time the Steelers scored 21 points or less. And again, this isn't exact, but roughly 75% of the time they scored 28 points or less. Don't get too concerned with that breakdown because the data isn't exact. Okay? But that's basically what a frequency table would look like and what your stem and leaf plots look like. Now, what we're going to do right now is we're going to create a histogram, again, based on that Steeler data set. I'm going to go ahead and get you started, and then I'll pause it and allow you some time to complete it on your own. But let's go ahead and give it this title. We'll go ahead and call it Steeler Points. Okay. And these, well, I'll tell you, I'm going to go ahead and hit pause right now and kind of get some more of the graphs set up. Okay, back to this idea of making a histogram. I went ahead and added some values here or some information. On the left-hand side, or the y-axis, we're going to go ahead and list the frequency of how many times the Steelers actually scored within a certain interval. And down here on the x-axis, this is a breakdown of the points scored in terms of intervals. You know, the first interval being from 0 to 9, and then 10 to 19, and 20 to 29, 30 to 39, and finally 40 to 49. Well, if you go back and look at your data, on 2 separate occasions, the Steelers scored between 0 and 9 points. So what we do is we actually draw a bar there, okay, showing that the Steelers twice scored within that range. The 10 to 19, the Steelers scored within that range 8 different times. So what we do is we draw a bar right up next to it. And these should actually touch, and I apologize for my crooked lines here. I'm doing my best. All right. But this is what makes a histogram. There's no space between the bars here, and it's showing the frequency with which it occurred in an interval. On 7 different occasions, the Steelers scored between 20 and 29 points. So we're going to go ahead and draw our next bar right here. And on 5 occasions, the Steelers scored between 30 and 39 points. So that's That's our next bar. And then finally, on that one occasion, the Steelers offense got it together and scored between 40 and 49 points. So this is essentially a histogram, okay? And again, I apologize for my bars being a little bit crooked, but hopefully you get the idea. And what that does, that gives us a breakdown of the data values, okay? Now, an interesting little side note, I'm going to backtrack here. If you take a look at the stem and leaf plot, and you kind of put, let's do it this way, little bars right here, I should call them little bars. But if you take a look at this value, these values right here in red, if you kind of tilt your head to the right 90 degrees, what you have is actually a picture of the histogram. On 2 occasions, we scored between 0 and 9. On 8 occasions, we scored between 10 and 19. On 7 occasions, we scored between 20 and 29, and so on and so forth. So a histogram is really just this stem and leaf plot turned on its side. Okay? All right. Back to the Steeler data here. Here's your histogram that they had asked you to complete. It's up to you if you want to put something like this and maybe little stars to kind of separate the bars. You don't have to do anything like this, but sometimes I'll see people do this just to kind of make it creative and colorful. But essentially, that's what a histogram is. Now, the next slide, I'm going to kind of blow through it. It's a little closer activity. I've already completed the data, or the values are filled in. Those are the correct answers. You're welcome to take a quick glance at that, but I'm going to kind of blow through it to be able to get through the rest of this video. We have 2 more examples to do here. This one's asking us to construct a stem and leaf plot based on the following data values. So we have these 5 values shown here. Our stems, if you take a look, are actually going to be 17, 17, and 18, and 19. And there's actually 4 values. I think I said 5. But I'm going to go ahead and complete this to save a little bit of time and show you what this completed stem and leaf plot would look like. Okay, here's the completed version of this stem and leaf plot showing the house values for 4 houses. Now this is a little variation of a stem and leaf plot you may not have seen, but the key to this problem is the key. It can be a little bit corny there, but if you take a look, we're not going to list every single value here and every single value here, and by that I mean all 6 digits. We're only going to list 3 of the digits. The 172,000 is going to be shown by the stem of 17 and the leaf of 2. The 179,000 is actually what I use for my key down here. That's represented again right here by the stem of 17 and a leaf of 9. So we show what this data represents by giving a good example over here in the key. All right, I showed it by having the 17 there as my stem, the 9 is my leaf, and again that's representing 179,000. And I guess you should put my dollar symbol in there. Okay. So that's a stem and leaf plot with the data being a little bit different, maybe something you hadn't thought of before. We have one final example. Again, it's going to be a stem and leaf plot with a little variation. If you take a look, this is representing the grade point averages for 5 students. Again, I'm going to go ahead and hit pause here and create the stem and leaf plot and then go ahead and explain it when I'm through. Okay, I'm back here now with the final example. And if you take a look at this stem and leaf plot, this is showing the GPA for 5 students. And what we did is we represented each of the 5 students' GPAs down here in a stem and leaf plot, but this one being a little bit different where the stems are actually the first digit of the grade point average and the leaves are the last digit, okay? And again, the key, once again, is the key to understanding how to interpret this. If you take a look, I have a 3 right here representing a stem, a 6 representing a leaf, and I'm indicating that interpreting the graph means that that is showing that it's representing the data value 3.6, and that data value is shown right here, okay? And again, that ties in with this GPA average right here. So I know I got a little bit confused there with all the drawings I have. Let me go and get rid of some of these arrows for you. But that's what a stem and leaf plot would look like. Again, a little variation what you might have seen before with stem and leaves. Anyway, I hope this video is helpful. Good luck with the problems you encounter. That's it.